Now let's just see some of the problems that are related with the theorem. The problems say that question number 1 is two circles of radii 5 cm and 3 cm intersect each other at 2 points. So it means we have to form the two circles that are intersecting each other at exactly 2 points. So let us suppose if with the question I'm just forming up the two circles over here. So let us suppose if I'm just taking the very first circle as this, and again I'm just taking the other circle would be like this. Okay, and further let us suppose this is the center and this is the center of the circle. Now first of all we know about this fact that whenever we are just talking about the two circles that are intersecting each other, and if they are intersecting each other at exactly the 2 points, then their centers always lie on the perpendicular bisector of the common chord. So since this is a theorem and we are using that theorem in this particular question, so always remember whenever we are just talking about the two circles intersecting each other at exactly the 2 points, then their centers always lie on the perpendicular bisector of the common chord. So if I'm just drawing up a common chord over here, let us suppose if I'm calling it as P, I'm taking it as S. Let us suppose if I'm calling it as O, I'm taking it as O dash, and if I'm joining this, so furthermore if I'm joining this, then definitely this O and O dash will lie on the perpendicular bisector of the common chord PS. Since we know that PS is nothing but a common chord, so obviously this portion is equal to this portion using that particular theorem. So let us suppose if I'm calling this point as nothing but R. Let us suppose if I'm taking it as R, and furthermore if I'm joining this point, and furthermore I'm joining this point. So let us suppose if I'm just forming up the two triangles over here. So what is actually given to us in the question? So first of all it says that the two circles of radii 5 cm and 3 cm intersects at 2 points. So as per the given question, since this is the bigger circle, this is the smaller one, so that's why I'm taking this one as nothing but 5 cm and I'm taking this one as nothing but 3 cm. So let us suppose if I'm just writing it over here that as per my construction I have taken OP as nothing but 5 cm. As per my construction I'm taking O dash P as nothing but 3 cm. This is actually given to us, and furthermore it says the distance between the two centers, means O dash is actually given to us as nothing but is equal to 4 cm. It says find the length of the common chord. We have to find the length of the common chord. Means we have to find PS. We have to find PS. So let us suppose if I'm just using that theorem and I'm just writing it up over here, that PS is exactly nothing but twice of PR. Why so? Because we are just using that theorem that whenever we have two circles and they are intersecting each other at any 2 points, then their centers always lie on the perpendicular bisector of the common chord. So using that theorem I'm just saying this thing. So let us suppose if I'll write the reason as well, since the two circles intersect at 2 points, so their centers would lie on the perpendicular bisector of their common chord. And using this particular theorem I'm just writing this thing that PS is actually nothing but is equal to twice of PR. Now furthermore if I just wanted to find out the value of PS, let us suppose if I'm just concentrating on PR only. So since it is nothing but a perpendicular bisector, obviously the angle would be nothing but 90 degree over here, as well as it is 90 degree over here as well. So let us suppose if I'm just taking this distance as nothing but X. So let us suppose if I'm supposing that let RO dash is nothing but is equal to X, then definitely if this is nothing but X, the whole distance is nothing but 4, then this distance would be nothing but 4 minus X. Obviously this is quite an easy thing because we know that OO dash is nothing but since O dash is nothing but 4 centimeter, it implies that OR would be nothing but O dash minus of RO dash. So OR would be like nothing but 4 minus of X centimeters. It is nothing but 4 minus of X centimeter. Now let's just apply the Pythagoras theorem over here, because we can see over here that we have the two right triangle over here. First of all, we are just taking the triangle ORP. So let us suppose if I'm just writing it up over here, that in the triangle ORP, we know that the hypotenuse square is nothing but is equal to perpendicular square plus base square using the Pythagoras. So we can say that OP square is nothing but is equal to OR square plus of PR square. Now let's just plug in the value of OP, which is nothing but 5 square. OR is nothing but 4 minus of X whole square plus PR square. So let's just calculate the value. It is nothing but 25. Let's just apply the algebraic identity A minus B whole square over here. So this would be nothing but 16 plus X square minus of 8X plus of PR square. So let's just calculate the value of PR square. So as you can see over here, if I'll take PR square on towards the other side, so it would be like 25 minus 16 minus X square plus of 8X, and at the end we are getting PR square as nothing but 9 minus X square plus of 8X. So this is nothing but the value of PR square that I'm getting over here. Now again, using the other triangle over here, which is nothing but the triangle PRO, let us suppose similarly I'm just saying in the triangle PRO, we know that PO dash square is actually nothing but PR square plus RO dash square. We can say this thing again. Now let's just plug in the value over here. This is 3 square, which is equal to, we just have to calculate PR square, and RO square is nothing but X square. So again, let us suppose if I'm calling it as 1. So from here we can able to calculate the value of PR square as nothing but 9 minus of X square. Let us suppose if I'm calling it as 2. Now first of all, we have the two equation over here, the equation number 1 and the equation number 2. Since both of the values are actually nothing but is equal to PR square, it means they would be equal to each other. So hence what we can say over here, hence 1 is nothing but is equal to 2. So which implies that PR square is nothing but is equal to 9 minus X square plus of 8X, which is equal to 9 minus of X square. So let us suppose if I'm just taking these two equal to each other, so it implies 9 minus X square plus of 8X is equal to 9 minus X square. Both of these values are getting cancelled with each other. So we are getting 8X is equal to 0. At the end we are getting X is equal to 0. So hence this is the value that we are getting from equating these two equations together. So let us suppose if I'll plug in the value of X is equal to 0 in any of these equations in order to get the value of PR. So we'll say substitute X is equal to 0 in equation number 2. Let us suppose if I am substituting in equation number 2, so PR square would be like 9 minus of 0, hence it implies PR is nothing but PR square is nothing but 9, which can be written as 3 square. Hence if I'll compare, so PR is nothing but 3 centimeter. But what is the value that we wanted to find out? We just wanted to find out the whole chord, common chord length, which is nothing but PS, and we already know that PS is nothing but twice of PR as per the theorem. So it implies that PS is nothing but twice of PR, which is nothing but twice of 3 centimeter, which is nothing but is equal to 6 centimeter. And hence at the end what we are getting the length of the common chord as nothing but 6 centimeter, which is nothing but our answer. So this is all about this particular question. So using this theorem, we have actually calculated the value of the common chord, which is nothing but the PS, whose value is equal to 6 centimeter.